Hello everyone, I am Anjali Bramne, Faculty of Civil Engineering Department from Vishwabharati Academy's College of Engineering, Ahilyanagar. Here I am representing online lecture series for fluid mechanics subject. Today's topic is Fluid Statics, Unit 1, Part B. First, we will discuss content of fluid statics. First, concept of pressure. Second, pressure head, Pascal's law, measurement of pressure, absolute pressure or gauge pressure. The basic equation of hydrostatics. Next, the application of the basic equation of hydrostatics. Principle of manometers, balancing liquid column, dead weight, pressure transducer, and their types. Center of pressure and total pressure on plane, horizontal, vertical, inclined, and curved surface and their practical applications. First, pressure. Definition of pressure is the normal surface force acting per unit area is called pressure. It is denoted by P. Next, fluid pressure, Pascal's law, fluid statics law. First, Pascal's law. See figure, the pressure applied on one point of liquid transmit equally in all directions. Next, relation between absolute and gauge pressure. Now see in figure, gauge pressure and absolute pressure. Next, pressure measurement device. There are two types, manometers and mechanical gauges. Again, manometers are divided into manometer, first simple manometer and differentiation manometer. Again, simple manometers, first piezometer, U-tube manometer, single column manometer, and differential manometer is divided two tubes, first U-tube and inverted U-tube. First U-tube differential manometer and inverted U-tube differential manometer. Again, mechanical gauge, first diaphragm pressure gauge, modern tube pressure gauge, deadweight pressure gauge, and bellows pressure gauge. Next, measurement of pressure. First, the piezometer is one of the simplest forms of manometer. It can be used for measuring moderate pressures of liquids. The setup of piezometer consists of a glass tube inserted in the wall of a vessel or of a pipe. Next, one end of glass tube is connected to the point where pressure is to be measured and other end remain open to the atmosphere. The rise of liquid gives the pressure head at the point. It is measurement of pressure. Next, limitations of piezometer. First limitation is piezometer can measure gauge pressure only. It is not suitable for measuring negative pressure. Second, piezometer cannot be employed when large pressures in the lighter liquid are to be measured since these will require very long tubes which cannot be handled conventionally. Last one is gas pressure cannot be measured with piezometer because the gas forms no free surface. Second is U-tube manometer. Now see in figure, pressure to be measured and atmospheric pressure. This manometer consists of U-shaped tube, one end of which is connected to a point at which pressure is to be measured and other end remain free to atmosphere. Next, the liquid generally contains mercury or any other liquid whose specific gravity is greater than the specific gravity of the liquid whose pressure is to be measured. Next, U-tube manometer. First, for gauge pressure and for vacuum pressure. This figure is for gauge pressure and figure is vacuum pressure. Third, single column manometer. Vertical single column manometer and inclined single column manometer. Next, differential manometer. First figure is two pipe at different level, and figure B A and B are at the same level. Next, inverted U-tube manometer. Then advantages and limitation of manometers. Advantages, first advantages is easy to fabricate and relatively inexpensive. Second, good accuracy. Third, high sensitivity. Fourth, require little maintenance. And fifth one, not affected by vibration. Then limitations. First is usually bulky and large in size. Second, being fragile, get broken easily. Third, reading of the manometers are affected by changes in temperature, altitude, and gravity. Fourth, a capillary effect is created due to surface tension of manometric fluid. Last one is for better accuracy, many sieves of has to be measured by accurate means. Next, mechanical gauges. Mechanical gauges are the best instrument to measure high fluid pressure in hydraulic engineering, where tube gauge cannot be conventionally used. The principle on which all gauges work is almost same. Next, Borden tube pressure gauge, invented by E. Borden. It's a pressure responsive element is made up of bronze and steel in tube form. The outer end is closed and free to move. Next is inner end is connected to the point where pressure is to be measured. Last is due to increase in pressure, elliptical shape converted into circular, and this movement is measured through link and pinion. Next, working of principle. First is when a when a pressure is applied to the tube stretches outwards and the tube end is attached to a pointer using a link. The link gear system makes the pointer moves along the scale. Last principle is the circular motion of the pinion gear device derives the position of the pointer to indicate the amount of pressure applied to the Borden tube. This figure is Borden tube. Next, working of principle. First principle is when pressure is applied to the diaphragm, it flexes. Second principle is the movement is transmitted by a link that connect to the pointer. Third principle is the pointer moves to indicate the amount of pressure applied to the diaphragm. And last one is the diaphragm stays at the original position until a pressure is applied to it. Next, pressure transducer. First is resistive transistor, second inductive, third capacitive, fourth piezoelectric, fifth thermoelectric transistor, fourth six magnetoelectric, last seven radioactive. Thank you.